Alright, let's go over this one. State the number of possible zeros and turning points of this function f of x equals x to the third equals 5x squared plus 4x, then determine all the real zeros by factoring. So I first want to point out that this point in orange here, this last part, this is Thursday's lesson. And you already know how to factor, but I'm letting you know that orange is in Thursday's lesson. So, but you already know how to factor, that's a review. Okay, so it says state the number of possible zeros. So the first thing I'm going to do is I'm going to make sure my polynomial is in descending order. Class, is this going from biggest to smallest by the exponents?
Yes.
Yeah. So remember that's a 1 there, so you're going 3, 2, 1. I don't care about the numbers in front. The next thing I'm going to do is I'm going to locate the highest degree. Show me with your fingers what's the highest degree. It's a 3. Our highest degree is our n value. N is equal to 3. So, state the number of possible zeros. Well, my zeros is just equal to n. So, we're going to have, at max, 3 zeros there. Okay, so I've done that. And turning points. So let's talk about turning points. So right now I'm kind of just doing algebraically. Turning points is n minus 1. That's the equation or formula. So if my n value is 3, just put it in there. 3 minus 1 is 2. So at most we're going to have 2 turning points. Okay? So again, the goal by the end of the week is to be able to graph this polynomial without a graphing calculator. So let's go ahead and use Thursday's lesson with just basically factoring. Let's factor this. F of x equals x to the third plus 5x squared plus 4x. Now before I start this problem, I'm thinking about 3 letters of the alphabet. Talk to your partner about 3 letters I might be thinking about with the keyword this one. On the count of 3, ready? 1, 2, 3. GCF.
Wow.
Remember, ABC is standard form, and you might need it for factoring if you're using the X box, but before you do that, you want to make sure that this is as smallest as possible. So if I take out the greatest common factor, which is a X, class, what are we left with?
Squared plus 5x plus 4.
Now some of you said, well, Mr. Ng, what happens if I use the ABC? You can use the ABC to use your X box, right? So then if I just factor again, two numbers that multiply by 4 but add to be 5.
4 and 1.
What numbers?
4 and 1.
4 and 1. So if I multiply these, right, you're going to get x squared plus 5x plus 4, multiplied by x, and you get this. Okay? Now, all we did so far is factored, but I haven't found the zeros yet. So I'm just going to use the zero product rule. Zero product rule. Basically means you put each of these equal to 0. And then we just go ahead and solve these. I have x equals 0. Class, if you solve this, x is equal to negative 4, which we just talked about, right? And this one solves to be negative 1. And that should make sense because, count with me how many zeros I have. Ready, set, go. We just talked about that, right? Okay. Let's go ahead and graph the zeros. So with these three, I have x equals 0, x equals negative 4, 2, 3, 4, and x equals negative 1. Okay, in the beginning it said the highest power was the power of what? 3. Class, what type of function is that? What was the name of it? It's a cubic. And if you draw yourself a basic cubic function, it's going to kind of look like this, right?
Yeah.
So notice how in a cubic function to the power of 3, it starts down, ends down. So sometimes people like to have a clue. Well, if you look at the parent function, you can kind of sketch out what the children function would look like, right? So tomorrow's lesson we'll talk about multiplicity, and you'll learn how. I'll show it to you. These are the powers of 1. Notice how those are all odds, and you'll notice that if you look in your calculator, they're actually going to go through, or we're going to use the language shooting through, the x-axis. Shoots through at 0, shoots through at -1, and shoots through at 0. So, basically finding your highest degree. That tells you the max number of zeros. We have that. We have 3 of them. You could have 2 or 1. The reason why is that it might bounce off the x-axis, or it actually may not go through the x-axis. Our turning points are here in orange, right? From increasing to decreasing, and then decreasing to increasing. So those are all be our turning points.